Good morning, everyone. We welcome you to Chile and to Universidad Adolfo Ibáñez. We're gonna start our first plenary and introduction from Leonidas Montes in 30 seconds. So please take a seat, find your
Hi. Good morning, everybody, and welcome to all of you. Although some of you might think, well, welcome to Latin America, we have a change in our program. Our president, Andres Benitez, was invited to a special session on education at our Congress, so he won't be able to address you this morning. He asked me, as Dean of the School of Government, to say only a few words, and believe me, I will keep my word. On behalf of Universidad Adolfo Ibáñez, it is our privilege to give you our warmest welcome to this Latin American and Caribbean Economic Association and Latin American chapter of the Econometric Society Joint Meeting 2011. Ibáñez University began in 1953 as Escuela de Negocios de Valparaíso, a business school that was the first of its class in Latin America. In 1988, Escuela de Negocios de Valparaíso became Universidad Adolfo Ibáñez, offering careers not only in business administration, but also in engineering, law, psychology, journalism, and humanities. Along its life, our university has participated in the public debate promoting a social market economy and a free society. Economists like Ludwig Erhard, Friedrich Hayek, and Milton Friedman have visited our university and they have received honorary degrees. We are very proud to have them among our honorary fellows. Graduate education plays an important role in all our careers. For example, our School of Business is ranked as the best business school in Latin America. We have a multinational MBA program in Miami and a global executive MBA with UCLA that takes place in Los Angeles, Santiago, Miami, and Sao Paulo. And our School of Government has a Master in Economics and Public Policy, and it is involved in the daily public debate. But beside our efforts in graduate education and research, Ibáñez University pursues academic innovation with an educational model that strengthens our professional and the graduate careers within a liberal arts curricula. During the last 10 years, we have focused on introducing a liberal arts education in our country. In Latin America, we don't have a tradition of liberal arts educations, as universities specialize mainly in professional matters. But we have dared to challenge our undergraduate students with an innovative model that comprises up to 30 courses of professional education and nearly 50 liberal arts courses. This model has shifted the teaching process into a learning-teaching interaction. For us, the classroom is not simply the place to listen to the lecturer, but it is the arena where opinions are given and discussions take place. It has been a real challenge to organize this Lacea Lames 2011, and it is an honor to welcome you all at Ibáñez University. I would like to thank you for accepting our invitation to participate. I really hope you have a wonderful time in Chile. This conference, as Hayek would say, is a consequence of human action but not human design. So many thanks to all of those involved in organizing this conference, and our special gratitude to those who are sitting with me here. The chairman of the board of Universidad Adolfo Ibáñez, Mr. Pedro Ibáñez, for his leadership in the shaping of these wonderful universities, the dean of our School of Business, Alfonso Gomez, and our vice president, Rafael Maquerone. Last but not least, I leave you with Ricardo Hausmann, president of the Latin American and Caribbean Economic Association, for his presidential address. Thank you very much.
Well, good morning and welcome everybody. Buenos dias. It's really an honor and a pleasure to have this inaugural session of Lacea. I forget how many meetings. This is meeting number what, Matias? 16. 16. We're not getting any younger. It has become, you know, the standard, the most important, the most significant meeting of academic economists in the region. It's a younger organization than the Latin American meeting of the Econometric Society. I know how difficult it is to organize these meetings because I also organized one for the Econometric Society back in 1994. So I know the enormous amount of time and effort that it takes. So I would like to thank Andrea Repeto, Matias Brown, and Fernando Larraín for their enormous effort, for all the people who participated in the program committees, for the sponsors. It's really, really an achievement. It also gives me a lot of pleasure. At the beginning of Lacea, we had essentially 4 universities in Latin America that had the capacity to organize these meetings. There was, you know, the ITAM in Mexico, there was Los Andes in Colombia, there was Aloisio Araujo in Rio. You know, there were 3 or 4 people. Now, each time we have new universities, new institutions that have the capacity to host these meetings and to organize them. And so it's with real pleasure that we are here for the first time in the Universidad Adolfo Ibáñez. Last time Chile organized this was 12 years ago, but now that there are so many new and vibrant universities, we hope to come back to Chile in a shorter period of time next time. So I would like to thank all the people involved in Lacea, our treasurer, our secretary, Monica Parra, and the members of the executive committee for keeping this as a vibrant organization that provides services and that provides networking possibilities and academic opportunities for its members. So having said that as president, let me go now to academic stuff, and I'm going to talk about this paper. The paper I'm going to talk about is based, or is an extension and elaboration on a book that we've just put out, which is called The Atlas of Economic Complexity. If you have not taken a look at it, it's available on PDF in the website, on the web, and it has a website where you can generate for yourself a lot of the graphs and data that I'm going to be developing and using for this presentation. And I would like to thank my co-author, Cesar Hidalgo, who's Chilean. He's not an economist, he's a physicist, but he's a superb guy, and it's been a pleasure to work with him. You'll have an opportunity to listen to him in a different session later on in the program. So this talk is going to be based essentially on answers to the fundamental questions in economic development, which is, why are some countries rich and why are some countries poor? Why some countries are catching up and other countries are not catching up, and what can be done about the accelerating this development process. So that's the question. So it's a very, very old question. There's nothing new about the question. Now, we all know the data, and the data is that, for some reason, the US, say, take a rich country, had an exponential expansion of its income per capita. It has gone up by a factor of 25 since 1820. And so the question is, what caused income to go up by a factor of 25? And we know that this has happened in the US, but it did not happen everywhere in the world. What I'm putting here in this graph is how many times richer was the US than the countries that are highlighted there, China, India, and Nigeria. And the US was about 2.5 times richer than China back in 1820. By 1970, it was 20 times richer than China. It was about 20 times richer than India. And so there's this process that happened in the US and in other rich countries did not happen everywhere in the world. But if you look at the more recent data, China has been catching up significantly. Now the US is only like 5 times richer than China. It's like 10 times richer than India. So these countries have been converging, but not all countries have been converging. Nigeria is now poorer in relative terms to the US than it was back in 1970. So some countries are still diverging. Other countries have been converging. So we want stories or explanations for why these phenomena happen. So why did the US become 25 times richer than in 1820? Well, we owe it to Bob Solow to realize that while we think that we make things with land, labor, capital, and human capital, that essentially the reason why we're 25 times richer is not that we have more land, more labor, more capital, more human capital. That's not where the answer is, okay? The answer has to do with the fact that we learned how to do more products, and we learned how to make better products, and we learned better ways of making products. So the products that you have there in the chart are not products that existed back in 1820. So it's not that we're producing 25 times the things we were producing in 1820. It is we learned to make many, many other things. So when we say we learned to make many other things, who is the we? Who are we talking about that learned to make more things? Who is it that accumulated all this knowledge about making these different kinds of products? Now, to understand the answer to that question, we can ask the following question. Who has more productive knowledge? Okay, an Inuit. So let me show you what an Inuit looks like. Here is an Inuit in food production. And here is an Inuit in housing construction. And here is an Inuit in transportation machines. Okay? So that's an Inuit, and this is modern man. So if you ask the question, who knows more, who has more productive knowledge, I would challenge you to come up with an answer to that question, because this guy who you have there, he uses glasses. He has no idea how glasses are made. He uses a telephone. He doesn't know how a telephone is made. He uses a computer, has no clue as to how a computer is made. He uses a shirt and a tie. He doesn't know how those things are made. Okay? This guy is fundamentally useless. He doesn't know anything. He can't make anything himself. If you put this guy where the Inuits live, he doesn't last a night. He'd be dead by the morning. So this guy cannot, the answer cannot be that this guy knows more than the Inuits. So that cannot be the explanation for why incomes have gone up. So The implications of this is that we cannot say that we have more productive knowledge as individuals. We can only make this statement about the society, not about the individuals. So why is it that we as a society have more productive knowledge than the Inuit society? Well, essentially because the things that were known by the Inuit society were known by everybody in the Inuit society. While the things that are known in our society, we only hold a minuscule fraction of the known as individuals. So what is happening at the social level is the fact that different individuals hold different pieces of knowledge. When Harvard was created in 1636, we had one college degree that lasted 4 years. Since then, knowledge has expanded enormously, say by 50 times. As a consequence, college degrees today do not last 200 years. They still last 4 years. But now we have 50 different majors. And it's through that division of knowledge in different heads that we are able to hold more knowledge socially. Now, productive knowledge needs to be in brains. We tend to think that productive knowledge can be on the web, or can be in books, or can be in somewhere else. But whenever your tooth hurts, you have two options. You can tell your significant other to download an article from Wikipedia and read about it and then fix it, okay? Or you can go to a dentist. Now, this suggests that the productive knowledge that matters is not a productive knowledge that is on the web or that you can read about. It's a productive knowledge that is in your brains that you can use to do things with, okay? So that productive knowledge is going to be hard to acquire. In the models we write, technology is something that's in the air. It's an A that multiplies K or L or H. It's in the air. This one cannot be in the air. It has to be in people, in individuals. It has to be in brains. And because of that, it's going to be hard to acquire, okay? So let me illustrate how hard it is to acquire. So this guy here is, as you can imagine, this is Michael Jordan. And here is Sports Illustrated saying that Michael Jordan is why he's the greatest player ever. And one day Michael Jordan decided to become a professional baseball player, okay? And here is Sports Illustrated asking him to quit, okay? Because, he didn't have the 10,000 hours that go into identifying what is a slider, what is a fastball, what is the ball going to. His brain is not fixed to be a great baseball player, independent of his raw talent. So even a guy as talented as Michael Jordan cannot hold the productive knowledge of being both a basketball player and a baseball player. So because it is hard to acquire, we are individually limited to how much productive knowledge we can hold. And the amount of productive knowledge we can hold, we're going to define as a unit. So we're going to call it a person byte. That's the amount of productive knowledge you can hold as an individual. And the thing that is going to be changing throughout society is, in essence, how many person bytes does a society hold? So an Inuit society, essentially, may have 1 or 2 person bytes because everybody has more or less the same person byte. And what has been happening, say, in the last 200 years, is the expansion of the set of person bytes, of different units of knowledge that is stored in different brains. Now, productive knowledge is then embedded in products, and you access the knowledge of others through the products that they are able to make with that knowledge. Now, products are going to differ in the number of person bytes they require. There are going to be more complex products that require more knowledge, less complex products that require less knowledge. But to make products that require more than 1 person byte, you need to put people together to cooperate in some way. So that's going to have to be done through cooperation in firms or through cooperation across firms, by some firms embedding knowledge in intermediate inputs and transmitting it to the other firms. So you can think of the economy as the process whereby we access and mobilize and utilize this productive knowledge. So the other side of this accumulating productive knowledge at the level of society is the increasingly complex network of individuals and organizations that are holding and using that productive knowledge. So products are going to differ in the number of person bytes that they require, and you can imagine that these products may require a certain amount of person bytes. It can be done in a family farm, some of these, but you need the agrochemicals, you need the fertilizers, you need a set of other inputs that knowing how to make them is going to ask for more than 1 person byte. But here is another set of products that may require a different set of person bytes and maybe more absolute number of person bytes. And here is the 787 that actually requires companies that are spread over 6 countries and a bunch of different firms producing millions of pieces that go into making this product. So when you look at, at the world and you ask yourself, how many people does the typical worker work with? In the US, the number is that the typical American worker works in a company that has 100 workers, okay? That's the average American worker. That's the expected number of co-workers that he has, and I take that from a recent paper by Pete Clino and Chantache. India has 4 times the population of the US. So you would expect, well, maybe that 100 times 4 is 400. Maybe that's your expected number of co-workers that you would find in India. But actually, the number is 4. And that's going to be an interesting fact because obviously, if you think that each person, if you put 2 people together, you would have at most 2 person bytes if they don't have the same information, the same knowledge, then with 4 people, you can make 4 person bytes. The airplane, you needed many, many more person bytes, a much bigger division of knowledge and of labor. So it's going to be no surprise then that the informal sector that has these small units and so on, they cannot make things that are very valuable because these are things that require very few person bytes. And this is expressed in the structure of production and firms that exist in that society. Now, it's not just the size of firms that matter because this is a Chinese factory, and you can imagine that all these workers essentially have the same person byte, so there are many people doing exactly the same thing, as opposed to, say, a symphonic orchestra, where each one is incorporating a different person byte, a different set of knowledge that allows for production to take place. So, you're going to say, well, what you're saying is essentially you're talking about human capital. And in some sense, I'm not talking about human capital, at least in the way we have tended to model human capital. We think of human capital as something that is in the individual and that we measure in things like years of schooling. And since we know that not all schools are of the same quality, we want them to take the PISA exam to know how much of the material they actually learned. So when we aggregate standard measures of human capital, we are essentially asking ourselves the question, how much of the same national curriculum do people know? Or how much of the same skills that these PISA tests test for do people know? So you're essentially asking how much of the same knowledge do people have? And when we think of human capital externalities, we think of, what is the impact of the average years of schooling of a society on my productivity? And that's a typical way these papers have been written, okay? But actually, productive knowledge is a different thing. Productive knowledge is unrelated to the average amount of productive knowledge that the members of society have, okay? It is related to the diversity of knowledge that the members of society have, okay? So productive knowledge is an extensive measure of knowledge, while the standard measures of human capital are intensive measures of knowledge. And so they're fundamentally somewhat orthogonal to each other, even though there's going to be some relationship to it. So the story that I'm going to build up is a story that is not new. It's in many papers that, and I'm going to mention a few of them. One of them is obviously Adam Smith. Adam Smith said that the division of labor was the secret of the wealth of nations. Now, why was the division of labor so important in Adam Smith? Well, we don't get a completely satisfying story because it's all about this pin factory, and the worker could have done the pin himself, but it's just more efficient that, maybe time and effort or organization of the process. Why is it that 10 workers doing pins in different parts of the pin is faster than one worker making all 10 parts? In our reinterpretation, if you want, The reason why the division of knowledge is the secret of the wealth of nations is that it allows you to make things that embody more knowledge, okay? Now, initially, when the division of labor was invented through manufacturing, there weren't the killer applications that were going to use this capacity to embody more knowledge. So the worry of the time was that labor was going to become alienated, boring. As Alexander Hamilton said at one point, he said, you know, manufacturers are great because it allows you to use even women and children, because it's dumbed down the process so much that actually it dumbed down the process because they didn't have the killer apps that could use more educated workers in a more productive way. But history caught up with this expanded bandwidth that the division of labor allowed for the division of knowledge. Second, this is going to exhibit strong complementarities, because obviously if a product requires several person bytes, you need all those person bytes to be there to produce the product, okay? And so all these papers that assume strong complementarities, whether it's Murphy, Schleifer, and Vishny, or Kramer, or the recent paper by Chuck Jones, have that characteristic. It's sort of like the micro story that we would tell about why you need strong complementarity is that you need to aggregate these person bytes. Then there are many papers that, in order to explain development, have to assume that something is non-tradable, because if everything was tradable, the world would have converged. So there's something that is making the process non-tradable. It's pinning geography down for some reason, and Danny Roderick and Andres Rodriguez-Clare have these papers. They assume some inputs to be non-tradable. Well, the reason why these inputs are going to be non-tradable is that this productive knowledge is embedded in people and in organizations of people. So people are very poorly mobile, but networks of people are even that much less mobile. So a network of coherent people are going to be that much less mobile, so this is going to make non-tradability an important feature. Now, there is also a bunch of papers that using the Dixit-Stiglitz production function associate sort of aggregate measures of TFP with the number of intermediate inputs that you put into the production process, right? So, you know, whether you start with Grossman and Helpman, or again Howitt, or again Roderick and Rodriguez-Clare, or Acemoglu, Antras, and Helpman, they all have these models where one of the building blocks in that model is that the number of intermediate inputs is a metric of TFP. Well, the story behind it, why that makes why is that a reasonable assumption, is that more complex products require more person bytes, and these person bytes are costly to acquire, so there's cost to setting up a firm that is going to provide these differentiated inputs, and TFP is a reflection then of the amount of productive knowledge that is embedded in things. Now, all of this relevant literature uses Dixit-Stiglitz. Now, let me quote Paul Krugman's Nobel lecture, where he came up saying, look, there is no good reason to believe that the assumptions of the Dixit-Stiglitz model, which is a continuum of goods that enter symmetrically into demand with the same cost functions and with the elasticity of substitution between any two pairs, any two goods, both constant and the same for any pair you choose, are remotely true in reality. So, and he goes on to say, but we're going to use it just to make the case that, you know, intra-industry trade could be possible, right? So we are using it just because it's practical, it gives you closed-form solutions, it makes a point, but it's not true about the world. And it's really not true about the world, right? It implies a very particular topology about the structure of production in the world. All products are fundamentally identical, so the elasticities of substitution between Mexican oil and Saudi oil is the same as between Mexican oil and cars or airplanes, which obviously makes, you know, little sense, but I'm not going to make much about that. But it also implies that the cost of developing a new variety is constant and fixed and independent of your previous history. So if previously you made a short-range airplane jet, and you're now trying to develop a long-range airplane jet, the cost you'll face is the same as if you were previously producing shoes or cucumbers. That obviously strikes us as not possibly plausible about the world. So, and because of this it's hard to bring these models to the data, and there have been some papers that brought these models to the data with some effort. So what I'm going to do is I'm essentially going to develop an alternative to Dixit-Stiglitz, if you want, in terms of an empirical alternative to Dixit-Stiglitz, in terms of asking what is the actual structure of productive knowledge and of production in the world we live in. Now, there's a bunch of other stories that are dominant about the development process. One says that institutions matter, and you wonder why is it that institutions matter? Well, institutions are going to matter because they facilitate the coordination of different person bytes. It allows you to add person bytes, it allows people to hire each other, to put things together, and so on. Human capital might matter because while human capital is an intensive measure, you know, in order to be an electronics engineer, you may need to have some previous basic knowledge. So the specialization of knowledge can occur at a level provided you have some basic previous knowledge. So there is some interaction between human capital and the stuff I'm going to talk about, productive knowledge, but it's not a direct one. Human capital may also allow people to talk to each other, to communicate in written form, to share knowledge because they share some common structure of that knowledge. So human capital might be a catalyst. These intensive measures of human capital might be a catalyst of these other measures. And then finance might matter because, you know, you need to contract people and so on, so you need some costs that you need to cover, and so finance might be an additional catalyst to the story, but how much do you need to focus on these things to tell the story about growth is going to be an empirical question that we're going to address in a little while. So what I'm going to tell you in the minutes that I have left is how would you go about measuring productive knowledge of countries, or actually the productive knowledge of products? What are tools you can use to answer this question? Test whether this explains whether, you know, the level of income of countries. Develop a theory of how this productive knowledge evolves, and then test whether that theory explains why countries grow. Okay? So that's where we're going. So how would you go about measuring how much productive knowledge do countries have? Well, obviously, you would have to look at the world. And here's a picture of the world. You'll all recognize this picture. The only thing is that this picture is useless to calculate the amount of productive knowledge that countries have. But this picture is very informative. This is also a picture of the world. Here, every row is a country. Every column is a product. So there's 129 countries, 772 products. And each pixel there is how much of each product each country exported. And this is Feenstra's data set for the year 2000. So this is a picture of the world. Now this picture, I don't know exactly how to read it, but if you allow me to reorder the countries so that they don't appear alphabetically, and if you allow me to reorder the products so they don't just appear by their code, I get this picture. And this picture tells a story. This picture says that there are some countries, the ones at the bottom here, that make very few things, and there are some other countries at the top here that make everything. Now, if you look at it vertically, there are some products that are made by almost everybody. And there are some products that are made by very few countries. What gives it this nested triangular structure is the fact that the countries that make few things make things that everybody makes. And the countries that make everything make those things too, but make also things that few other countries make. Okay? Now, this is done with trade data. And trade data only has goods. It doesn't have tradable services, and doesn't have the whole non-traded economy. So you can do it if you have another data set, and we have here a data set for Chile, which I thank the Ministry of Finance of Chile for having provided us with this data. Here you have 347 municipalities and 700 industries. And here what we put is whether a certain industry is present in that municipality. Okay? And you have exactly the same shape, the same story. It's this nested story. Now this is going to allow us to rank countries in terms of the productive knowledge they have, in part because obviously if you take this graph here, Ghana, say, is a country that exports fish. Argentina exports fish, cheese, and creams and polishes, and Netherlands exports all those three plus medicaments and X-ray machines. So you can see that some countries possess a smaller set of productive knowledge than other countries, and it's expressed in the completeness of the productive structure. So what we're going to assume is that products are made with person bytes. And products differ in the number and the specific character of the person bytes they require. And countries are going to differ in the person bytes that they hold, okay? So when you put these two things together, countries are going to be able to make the products for which they have the person bytes that those products require. And so the interaction of these two matrices gives you what is it that countries make. So countries make what they make because they hold the person bytes that are required to make those products, okay? So what we want is a metric of these person bytes that is going to be reflected in the things that countries are able to make. So the intuition is going to be very simple. You know, the more person bytes you have, you'll have what it takes to make more products. So the more person bytes you have, the more diversified you'll be. The more person bytes a product requires, it's going to be accessible to fewer countries, because only the countries that have all the requisite person bytes are going to be able to make those products. So products that require more person bytes are going to be less ubiquitous. Countries that have more person bytes will be able to make products that require more person bytes. But products that require more person bytes are going to be less ubiquitous, meaning that countries that have more productive knowledge are on average going to be able to make products that are less ubiquitous. And you can keep this going. Now, products that require many person bytes are made by countries that have many person bytes, but countries that have many person bytes should be able to make many products. And in particular, they should also be making many products that require many person bytes, so they're going to make products that are less ubiquitous. So that information is contained in these matrices, okay? Now, what we're going to use as a technique to calculate how many person bytes a country has is the same technique that they use in college football. Now, in college football, because it's so costly to play a game of football, you cannot have all teams play everybody. So the way the champion is decided, or the qualifiers are decided, is first of all by how many games you won. But second, how many games were won by the teams you beat. Because some people may win many games against weak teams, and other people may be winning games against strong teams. So you want to know not just how many games you won, but how many games were won by the people you beat, and how many games were won by the people who beat the people you beat, and so on and so forth. So you're looking further and further at the network of connections between these things. So this is how it's done mathematically, okay? If you imagine a matrix, like this Chilean matrix or this other matrix, it's a matrix of zeros and ones. It has a 1 if a country is able to make a product, and a 0 if it can't make that product, okay? In that matrix, if you add over all the columns, it will give you the number of products that a country makes, okay? That's the diversification of a country, is the number of products that it makes. If you add over all the rows, it gives you what is the ubiquity of a product. Okay, how many countries make a certain product, okay? Now then you're going to ask the question, what is the ubiquity of the products that I make? That is, how many other countries are able to make the products that I make, okay? That is going to be this second set of equations here. Okay, this is how many countries are able to make the products that I make, and this is how many, that is, what's the ubiquity of the products that I make, the average ubiquity of the products that I make, and this is average diversification of the countries that make this product. Is this product made by a country that makes many things, or a country that makes few things, okay? That's an information about how complex the product is. Now, you can see that you can iterate this thing forever, and it becomes this eigenvector, this eigenproblem, if you want, where the value of this nth level iteration is a function of the n minus 2 vector plus this matrix, okay? And this matrix comes from multiplying the same matrix of countries and products with its transpose. And our metric of how much information is contained in the products of a country is just the second eigenvector of this matrix. So as you know, eigenvectors are a spectral measure of things. So if you think that light has an intensity, that would be like human capital, how much years of schooling you have. This is what is the spectral variance of the knowledge that you have. So it's the second eigenvector of this thing. And you can do it for countries and you can do it for products. So you can calculate what is the complexity, if you want, of an economy, or what is the complexity of the product by extracting that information from that vector. So here is our measure of economic complexity and income per capita of countries. In blue, you have countries where natural resources are less than 10% of GDP. And in red, you have countries where natural resources exports are more than 10% of GDP. So you see, for the blue countries, the correlation between this measure of economic complexity and income per capita is 75%. Now, countries that have large natural resource exports are richer than what those countries would have expected to be if you had used the blue regression line. So these countries have higher incomes, and you can posit that those higher incomes are coming from this other thing, not the knowledge that they have, but the natural resources that they hold. But if you control for the amount of natural resource exports that countries have, then you explain 73% of the variance of income per capita between countries of the world. Okay? So this thing is highly correlated with income per capita. So next thing you're going to ask is, how does this productive knowledge, how does this complexity, this spectral dimension evolve over time? And the answer is that, well, it's going to evolve by addressing a very important chicken and egg problem. The chicken and egg problem is that you cannot, how is it that a country starts making a product that it was not making before? Well, to do that, you'll have to have the productive knowledge that is required by a product that you have not made before. So imagine that this product is watches. You need both watchmakers and, say, precision machinists to make a watch. Suppose you have neither. Okay, then if you don't have them in your society, you can't make watches. Now, if there are no watchmaking industries, nobody wants to become a watchmaker. And even if they wanted to become a watchmaker, they wouldn't have other watchmakers to learn from the trade, right? And even then, if you were able to train some watchmakers, there may still be no machinists around, and you need both to make watches. So the only way we're going to be able to solve this problem is by addressing this coordination problem. So how does the world deal with this problem? And the proposition will be that the world deals empirically with this problem by moving from the products you're in to products that are nearby in some, person byte dimension. Now, how are you going to have a measure of the distance in person bytes between products? So here we do another trick, okay? We'll posit the following assumption. If two products require identical person bytes, the countries that have the person bytes to make one product are going to have what it takes to make the other product, and those two products will be co-produced or co-exported, okay? So what you have here, this is the products that, I'm looking across all countries in the world. When is product P exported together with product P prime? So the proportion of times in which they're co-exported divided by the maximum of the proportion of times in which either one product is exported or the other product is exported. So it's like the minimum of the conditional probabilities of exporting B if you export A, or exporting A if you export B. So that's our measure of similarity between products, okay? And with this measure of similarity, we can calculate the distance between all products in the world, and that's this product space that we published in Science in 2007. And Science was a little bit more open to these ideas than the American Economic Review. But so what you have here is each product is a circle, and it's connected to products that are nearby, okay? And this is a representation, it's just a graphical representation of this connectedness of the knowledge requirements of different products. Now, one of the reasons that makes this network interesting is that it seems to affect the way countries accumulate more productive knowledge. It seems to capture something about the way countries diversify. So this graph here is the same graph I just presented to you, where we have covered with a black square the products that Malaysia was exporting in 1985, okay? And the question is, does the evolution of Malaysia's productive knowledge have anything to do with this notion we're capturing here? Does this notion predict how their productive knowledge is going to evolve? So take a look at the black squares if you can with this slide. But this is 1985, 1990, 1995, 2000. So if you notice, if I go back to 85, and you look, say, around here, this cluster here is electronics, this is garments, this is textiles, this is cars, and these are chemicals, and so on. And this is oil at the end of the world here, and this is, products are differently located in that space and with a different number of neighbors. Some products may have more neighbors. If you have very close neighbors, means that if you have the knowledge that it takes to make one, it'll be easy to move to make the other one. So what you have here, say, if you look, say, around here or around here, 85, 90, 95, 2000, is that this productive capacity spreads in a way that is captured by the links in this product. Okay. So for this last publication that we put out a couple of weeks ago, we recalculated the product space with more recent data, and that's what it is. These are garments, these are construction materials, this is machinery, these are chemicals, these are electronics. This is the data self-organizing itself, okay? These products are very heterogeneous in two dimensions. One is in how many neighbors they have. So how useful is the knowledge you have by making one product if you were to move to make other products? That's this connectedness here. And this is how complex are the products in that part of the product space, and how many person bytes they require. So products are going to differ enormously in terms of their complexity and their connectedness. So let's look at the world through this lens. So you take here a country like Ghana. Ghana is a country that has made enormous strides in education. I'm here comparing the education of Ghana to the education of Thailand. And not only is that more years of schooling than Ghana, but also speaking English. So that's supposedly it's the lingua franca. The world is divided in two types of economists, those that only speak English and those that also speak English. So here and maybe because of that, Ghana is the success story of growth in West Africa, okay? Now, if you look before, well, it was not that great a success story before that, so it's, in some sense, it's a recovery story. And this is the structure of Ghana's exports. This big yellow thing is cocoa, and more cocoa, and this is aluminum, and this is wood. And that's essentially what they were exporting in 1975. If you look at how many other things did they learn to make, well, this is what happened by the year 2000. So that's cocoa, that's aluminum, that's wood, and here are some diamonds and some fish, and that's essentially the expansion of their productive knowledge in that 25-year period. So this is the evolution of their exports by composition, and here you have how they moved in the product space. So this is the same graph sort of I presented to you for Malaysia. These squares is where they had productive capacity in 1975, and they diversified out of there. So you see this by the year 2008, they have a much more, they completed their occupation of several parts of this forest out there, okay, of this product space. So that's Ghana, okay? So now let's compare it to Thailand. Thailand in 1975 was exporting 75% were agricultural products, sugar, vegetables, rubber, corn, and rice, and jute, and a little bit of fish, and a little bit of tin, and so on. By the year 2000, 50% of Thailand's exports were machinery, okay? And 17% were light manufacturers. And if you look at the evolution of their exports, it's not that they abandoned the previous stuff. The previous stuff is still there and actually in larger numbers. They just added a lot of stuff that they were not making before to the things that they were making before, okay? So when you look at Thailand in the product space, this is where they were in 1975. and this is where they are now. So you see 75 now, so there's a huge expansion of the productive knowledge of this society that is not at all captured by the evolution of human capital as measured by years of schooling. So when you actually look at the evolution of GDP of these two countries, the success story of Ghana is this line over here, okay? So I've tried to convince you that looking at the things that a country is able to make tells you something about what they know, and that this variable is a fundamental variable in the evolution of income and consequently of growth. So let me go back to this chart I already presented. This is the economic complexity of a country controlling for their initial income and their natural resource exports, and this is their GDP per capita. This is controlling for their natural resource exports, and this is GDP per capita. So you see we have this R square of 0.73. You're going to tell me 0.73 is nice, but it's not 1. You're making errors. There's some defect in this economy. For example, India is a country that should be much richer than it is, given what the person bytes that we say it has, while Greece is a country that is too rich for its person bytes. Now you can say, is this an error of the theory, or is this an error of the world? Maybe it's the world that is wrong, and Greece should be poorer, and India should be richer, and maybe this error is actually going to be driving future growth. And that's exactly what we observe, that the difference between the person bytes you have and your level of income affects your future growth. So let me show this in terms of a set of regressions that I'm going to get to the regressions after I introduce an additional concept. So it's not just how complex you are, it is also how centrally located you are. Because if you're in a part of the product space that has many neighbors, you're going to be able to move to the next product by solving very few of these chicken and egg problems. But if you're in a part of a product space where there are fewer neighbors, the next product will be many person bytes away, so it will be harder for you to jump that chasm, okay? So we want to develop a measure of how well located you are in this product space. And this measure is going to be based simply on the question of how far is your current production, the things you currently know how to make, from the things you don't know how to make, okay? Weighted by how complex are the things those things that you don't know how to make. So that's essentially another manipulation of these same matrices, but this is the number that you get. So this is essentially the index of economic complexity I already presented to you, and this is how well located you are in terms of how many other products you have that are near the products, how many other products you're not making are near the products you are making, okay? And you have this shape that we're going to come back to it that looks to me a little bit like the Italian boot or something, right? Okay, so countries here have few person bytes and are very far away from the next product. Countries here have an intermediate number of person bytes and they're very well located. And then there are countries here that are pretty much everywhere and they have nowhere else to jump. They have already producing everything. So they don't have many other products to jump. The only way they can keep on jumping is by planting new trees, that is by inventing new products that did not exist before. And that's sort of like what Philippe Aghion would have called the frontière. No? So if you look at the evolution of countries in this space, okay, this is essentially the index of economic complexity, the number of person bytes you have, and this is how well located you are in the product space. You see, Ghana has been moving essentially around areas of very low complexity. Thailand started here, moved initially to areas that are more connected, and then kept on expanding its number of person bytes and moved to areas that are more connected, and then ended up with a very diversified economy that is quite well connected and making quite complex goods. While Colombia is this intermediate country that started better than Ghana, but it got sort of like trapped in here. Maybe now that they're making more connected products, maybe they'll be able now to move to the right faster, but they were overtaken by Thailand in this process, okay? So let me show you some regressions with these variables. So, this basic equation, okay, we're going to control for initial GDP per capita, and natural resource exports, okay? With those two variables, the natural resource export growth, you get an R-square of 0.17, okay? With just initial GDP per capita and the growth in your natural resource exports. So we're going to add first the index of economic complexity and then this opportunity value, how well located you are in the product space. And these two variables are highly significant and they essentially double your R-square. Now we're talking about an R-square of, say, 0.33. These are decade-long rates of growth. Okay, so let's compare a little bit how this regression does vis-a-vis, say, including other things. So here's credit to the private sector. So here's, we repeat it with the same sample for all these things. So it's 273 observations. In this sample, the two initial control variables gives you an R-square of 0.18. If you put our two variables, it doubles again to 0.36. If you take away our two variables and you put financial depths, it essentially increases the R-square very marginally from 0.18 to 0.19. And when you put all of them together, essentially credit to the private sector as a share of these disappears, and actually incorporating it gives you 1 degree less of freedom, and that's enough to bring your R-square down. So essentially, there's no additional information in financial depth. Okay? So let's do human capital. Okay? So same story, we repeat with the same sample, 269 observations. The R-square of the two initial control variables is 0.18. When we put our two additional variables, we increase it to 0.28. If you take them out and you put years of schooling, you go from 0.08 to 0.16. So it's a significant increase, but much less than ours. If you expand with other measures of human capital, it doesn't do anything. When you put our variables and human capital, you essentially get 2 additional points of R-square. Our variables remain statistically significant, and so does human capital. So there's some complementarity between human capital and the variables we're measuring, but the bulk of the explanation is carried out by our variables, not by the human capital variables. When we do the quality of government, well, you know, this is a well-established fact in the empirical literature, not in policy debates, but essentially the quality of government has no predictive power over future growth. On its own, with, you know, whether you use the ICRG for a longer time period or whether you use the world governance indicators. Essentially, with the world governance indicators in this sample, our variables you know, double the R-square, but none of the variables of the world governance indicators have any traction in terms of predicting future growth. Countries that have better institutions, at least in this sample, don't grow faster. So economic complexity index and opportunity value help explain a significant fraction of the variance of growth of countries. Okay? And this effect is robust to the inclusion of these other popular variables that have garnered a lot of attention in terms of focusing the areas of policy reform. So now I have to answer the question why some countries are catching up and other countries are not catching up. Okay? So that answer is sort of like captured by this graph. Because if this graph is going to tell you how easy it is for countries to expand their productive knowledge, well, there are some countries that are going to have a lot of trouble growing because they have very few person bytes and very difficult time accumulating more person bytes. So this is how easy it would be for you to accumulate more person bytes. There are some countries in the middle where it will be very easy for them to catch up because they are very well located in the product space, easier for them to move. And then the rich countries are going to have a harder time because they have fewer places to go to. So when you actually use our equation to predict future growth, it gives you this sense that for countries that are at low levels of income, some of them will not be catching up, while other countries will be catching up very quickly vis-a-vis the rich countries that are going to be growing at a more moderate rate. So in some sense, the information of not only why some countries are converging now and others not, is sort of like captured by these things, and why the rich countries cannot grow that fast. So let me skip these. This equation just shows that the evolution of your person bytes is regulated by your position in the product space. Okay? So your position in the product space explains the speed at which the complexity of your country grows. So in that sense, that Italian boot is so let me skip there because so why did we have divergence over 2 centuries and convergence now? Why did China become a 20th of the US economy and why it's now a 5th of the US economy in income per capita? Well, it's interesting if you look at this graph, how the technological shape of the world has been changing. So this is the economic complexity index and opportunity values of your position in the product space back in 1978. And you see that it used to be this sort of like the green line is a non-parametric adjustment to that series. It used to be that the only countries that were well located in the product space were the ones that were the richest or the ones that were more complex already. So, and what has happened over time is that this hump has been moving to the middle of the distribution. And that's an interesting fact. There's an interesting fact that there's been this evolving shape of this product space. This technological connectedness between products has been changing. And what, well, I'm going to say a few things. So let me sum